last time I was taking an interview, right? Your opinion about right arrow, not right, red arrow, correct? Which corresponds to excitation from ground state to first excited. And if we arrange it to be half 50% excitations, then it will relate to bouncing of electron forth and back. And you already did it in the lab, and some of you even submitted the homeworks. And either everyone or a vast majority submitted the YouTube videos. So the today's and Monday's meeting are, again, absolutely useless. We will just attempt to, yeah, sorry that I didn't tell you, and you didn't say for a visit. The goal is to reproduce the same things as you did with MATLAB by pen and paper. And since likely neither you nor myself like exams and solving problems, it will not be any form of like testing if you absorb it better. But I hope and wish that by following what I do or trying this exercise, you will believe in your own strengths that modeling and prediction of the future can be done without computers. And you will see that you didn't waste time in your high school when you were studying trigonometric functions. About at 80% of the time towards the end, so about 11:40, I will invite those who are in class to come and help me derive something on the screen. And I have forgotten that Friday, some people like to stay online. Next time, probably I will make this exercise through Google Docs so that everyone can make this little help. But it will be quite easy, and it's not a big secret. We'll just evaluate one of the trigonometric functions. Okay. Planning to go to the share screen mode. So the only background for today's meeting is to know the anatomy of camels. So if you understand basics of this anatomy, you will succeed today's meeting with guarantee. So let me ask you whom you see on the screen and what is the difference between these three images.
The peaks or whatever, like for example, like in the middle, both the camels peaks are equal. In the left one, we have one higher peak and the other is lower. And then in the right figure, the first peak is lower and then the second peak is higher. So the peaks.
Thank you much.
Mains.
Allison?
They're called the mains.
Mains?
I think so.
Okay. So humps is not a good word. Mains is better. Okay, yeah. Thank you, Allison. So you'll study the mains, humps, and peaks of the camels. Yes, you are absolutely correct. So the height is different. So I don't know, maybe it looks crazy from your point of view, but I identify some similarity with the image that you have completed in our MATLAB session. So there are this mains, humps, peaks that alternate the heights. And the goal is to get these shapes without help of computer, assuming or hypothesizing that we are on the inhabited island without computers and electricity, but we still, by some reason, need to look for excited state of electron in a box. So by the end of this subject, I want to arrive to this figure, and depending on how efficiently and quick will be our interaction, or how efficient and quick will be myself, we can either make a stop when time is over, or maybe we can arrive to this picture by the end of this, like half an hour. So this will be an equation for probability distribution of the electron, which is in the superposition between ground and first excited state, and we will explore it at certain instance of time, like initial time, quarter period forward, half period forward. And for this simple system, everything can be reduced to relatively simple trigonometric expressions that can be plotted even without a computer. And the difference will be like a product of two factors. First factor will be always sine square of the half period frequency. And the second factor will be square of either 1 plus 2 cosine, 1 minus 2 cosine, or 1 plus 4 cosine square of the same argument. So if one plots these equations, one will get the images that Sibel did prompted to us. And basically, my goal is to convert everything we discussed last Wednesday into this images, or into these equations. And maybe to show that plotting this equation will give these images. Well, not literally the animal of the desert, but the shape with manes higher and taller. So there are already several homework submitted, and for coming Monday and later on, we will have another homework which I may type better, but you can look through. So I'm just giving a little heads up. Right now, we are looking for one-dimensional box, right? We neglect motion, we consider motion in X and neglect motion in Y and Z, because we assume that it is unlimited and can go as free space. Next week, we will consider box that where the molecule is not just linear oligomer, but some three-dimensional structure, which is confined in several dimensions. And one can design boxes, like rectangular boxes of different shape, like a box for ski, to travel to a ski resort, which is elongated, a box for pizza, which is flat, or just regular FedEx box, which is approximately cubic. And the energies of electronic states in these boxes will be quite different, so that experimentalists can look in on the levels, can immediately say what was the shape of the box. So those Lx, Ly, Z are sizes of the box, and we will dive into this activity next week. So right now we are covering density metrics. So here is our favorite red arrow, what we actually consider, and here is the summary of this new methodology that we did. So our system is in the superposition of first and second eigenfunction with expansion coefficients C1, C2, which are equal. And instead of wave function, we are looking on probability distribution, which includes product of the eigenfunction, right? With either another one or another index, and time-dependent combined expansion coefficient, which includes either one or another, and accumulation of time, which accumulation of phase, which is proportional to energy difference between these levels. Please confirm if these two equations, well, I would never expect it makes you happy, but at least that is acceptable and you permit me to go further. Yes? Okay, thank you. So last time we were opening it in explicit form, where I and j takes values from 1 to 2, and then there were 4 terms. And now we do have only, we have summation, more general form. Okay, so when we plugged in expressions for energy for spatial parts, we've got that there is a, so we open this summation, there is a term with a square of the spatial half period, square of the full period sign, and then there are cross terms that may change their sign. So first two are positive, last two alternating sign, and first two do not change over time, and last two change over time as imaginary exponentials. But since the spatial part is absolutely the same, we can put it out of bracket and add together these two exponentials, right? And by Euler equation, it is expected to give us a cosine. Please confirm. Okay, yeah, thank you. So we are doing nothing but exploring this equation. And let's look onto this summation of exponentials, or cosine. So we may realize that this probability distribution will be summation of these three functions, but the third one will come with different phase, different proportion, positive or negative. And this proportion is changing over time as cosine of the time, right? So the computer and appropriate script that we were practicing was exploring all points subsequently, one after another. But if you want to do it by pen and paper, it's a big luxury that is not accessible for us to do it again and again at fine grid points. We probably can explore a couple of specific interesting points, and then as humans who are typically smarter than computers, assume that everything between these interesting points will be can be interpolated. So we can look time equals 0 when this cosine comes equals to +1, right? We can take 1/4 of the period when the phase is pi/2, and then cosine will be equal 0. And we can take half period when cosine is -1. And then if you go further, there will be another point which when it is 0, another point when it is +1, and everything is between can be complemented by our brain, assuming that it is interpolated in between. So if you want to be careful and in processing this idea, we can extract the period of these oscillations. So period is what is, if you assume that we have like cosine of T over T capital times 2 pi. So we want to identify, so it is something that stays in the denominator in respect to time. So this period will be inversely proportional to energy difference, right? And it will be directly proportional to 2 pi and directly proportional to h bar. So just inverting stuff here, we can get a period of these oscillations. And if we measure our time in dimensionless units, we can say just which portion of period has passed. If we do not do it, the grader who grades our work or reviewer who reviews our paper will say, I'm not sure if you have so many femtoseconds, you need to give exact figure, exact number. And if we just do relative dimensionless units, then our hands are free. We will be always correct. So, according to the definitions that I'm not sure if you were happy, but at least you silently accepted, the coefficients which eventually depend on time are referred to as elements of density matrix. So 1 for this shorter periods, longer period spatial thing, 2 for this higher energy, more frequently changing, and summation of 1, 2, and 2, 1 for this transition states that corresponds, that have this mixed cross-term indices. So we want to evaluate each of them at the time corresponding to 0, pi over 2, and pi. So let me, so prepare. I would like you to come one by one and scratch something on the screen. Sibyl, would you like to come? And I'll help if there are some challenges. So since we are outnumbers, you can fill couple. So at time 0, what will be the row 1, 1? Yeah, we can just use, yeah. So, uh-huh. Uh-huh. Yeah, that's good. We would change at another time. Does this, no. So let's go forward and so row 1, 1 will be 1/2 again. We would change at other time. When we scroll time, it's okay. Just put on. Yep, thank you. Let's thank Sibyl. So, Joe, please come and help us. There are a couple of simple examples and a couple of more complicated. So those who will come later will have a little bit of challenge. So would you like to feel something?
Yeah. Also be one out.
Yeah, keep going. Well, just keep feeling. We all noticed. Okay, yeah. Let's thank Joe. So, Adam, please come and help. So you need to break this pattern. It will not stay anymore for next. So it's cosine of 0, which equals toughest question. Yeah, excellent, thank you. Wade, would you please come and help us to evaluate cosine at some other instance of time? Excellent. And can you just give the answer for the last cell? Excellent. Yeah. Thanks, Wade, and thanks, Adam. So right now, you are familiar and closely acquainted with density metrics, right? So you can predict density metrics at at several points of time, and you see it's not very scary. Diagonal elements or indices are the same, typically do not change, and they correspond to population of levels, probability to be occupied, and the off-diagonal change over time, which is related to some dynamics in space and in time, and something changes, and sometimes they are called transition elements. Lower, I do not see the you're not in class, otherwise I would approach and ask you in person, but do you remember anything about transition in time-dependent density functional theory? Can you comment?
Transition.
Like when you plot NTOs, what does it relate to?
Orbital.
No, natural transition orbitals. So they are not orbital same as for ground state. Transitional means they're composed of transition density metrics, because they are done for absorption when system is in transit from one state to another one. Make sense?
Yeah.
Okay, yeah, thank you. So there is a relation to the subject of density metrics and some advanced computational calculations. Okay, so you see that in previous years, few people did it more or less successfully, but this year we did it quite quick. And let's check. Yeah, we are quicker than last year. So we have 20 minutes more. Now, let's evaluate our probability distribution at different instance of time. So no, this is ugly. I'll probably focus at here. So at time 0, we do have contributions from ground state, which is half period, and it is squared. Excited state, which is squared, but there are 2 pi, and there is a transition state, which is a product of these signs, right? So it comes with factor 1 because of Adam, because time-dependent factor gives 1. And now we have a high school math problem to plot this function, or maybe before plotting one can simplify it, because products are always simpler to plot than summation. So some hints are already here, but what do you see when you look on this equation? Which thoughts visit you? What do you think by looking at this first line at times equals 0?
you you simply split them up into their squares and respective variables.
So one can identify a full square, right?
Yes.
Okay. Anyone wants? Thank you, Adam. Anyone wants to add? Everyone agrees. Okay. So we can the sign of x by x o l as one new variable, sign of double argument as another variable, and then one can identify that it is first variable squared, second variable squared, and then double product of them, right? Which is first plus second squared. Now, thanks to White, the this probability distribution at a half period in the last line will be very similar, but if you have the minus sign up front of here, right? So would you agree that with flipping sign, it will be also full square with negative, right? And in the middle, we do not have the last term, so it will be just adding together this square of single argument and square of the double argument when it flips more frequent. So the only goal I want to pursue at this time interval to plot these functions, and before plotting, maybe to simplify it a little, even further. So what can we do for simplifying? Can we identify any factor that can be placed out of brackets? Is there anything that is repeatedly appear in each of these expressions? Any candidate to put out of brackets? Yeah. Or how can we put sine square of single argument out of brackets here? Yeah, if you put this one out of brackets, how? So here is a double sign. What should we do to this sign of double argument to factorize a sign of the single argument out of it? Exactly. Yeah. Thank you, Joe. So it will be sine times cosine, and then this term will include sine that we can put out of brackets. Yeah. Thank you. I was correct in my guess that this year we will go quicker. Thank you for participating and for doing great in high school. So if we identify the double argument here, we replace sine of double argument as sine times cosine, and then the sine can be placed out of brackets, and because of this square, when we place it out of brackets, it will have second power, right? In the last one, we do the same trick. We put sine square out of brackets, and inside we have a minus. And if we process the middle term, then as Joe has suggested, to identify the double argument, so sine of 2 pi x will be sine pi x sine cosine pi x, and we identify that there is a sine square of pi x that we can place out of brackets once again, right? Now we can, this format is already acceptable to plot without a computer. So if I look onto the first snapshot, so I may focus on the double cosine. So then it will start at 2 instead of 1, right? So we just multiply it by factor 2. If I add 1, it is just shifted up, right? So it will change from -1 to +3. And what is interesting, after this shift up, this red line will intersect x-axis at a point which is shifted from the center, right? So if we do our next operation, if we take square, then everywhere where it is 0 and it is only 1 point, it will stay 0. And when it was negative, it will flip sign with some additional cosmetic changes. So new shape will go this way. And now we, yeah, so it is this black line. And if we multiply it by sine square, which is definitely, it must be 0 at left and right boundaries, it will mean that we will take these boundaries and drop them to the to 0. So it should be continuous line starting at 0, then ascending, descending to this point, and then descending once again to 0. Make sense? So here is green dashes is sine square, and here the fat thick blue is the shape of the wave packet. So these probability distributions which do not have imaginary parts are often called wave packets because it's wave and it is consolidated and moves as a packet. So I think it is camel number 1, right? Where the front main hump peak is smaller than the second one. So one can practice the same exercise by putting the minus sign here. Then the cosine will move down and the point of intersection will move to the left, right? And after multiplying by sine square, the distribution of heights between peaks will alternate. So probability distribution will be still positive, but the it will touch the x-axis at the point around maybe 0.4, right? So it will be camel number 3. And if you look to the midpoint, then this cosine square doesn't touch 0 anywhere, and due to the let's check why should it have a dip in the middle. Is there any so cosine gets positive and negative? But cosine square is always positive. Let's check how do we get it. No. Let's find it out. I don't have pre-made notes. So what are your ideas? How can we prove that it will be symmetric and will have this shape? So if we draw cosine for this half period, no, it's full period, right? Check quickly if there are better notes. So when cosine intersects 0, but then we take square of it, and then it becomes positive, and then we shift it by +1, and it will be minimum in the center, maximum on the edges, and when we multiply it with sine square, it will generate this two peaks. Whew. Let's return back to pictures. So basically, we got what we wanted, right? If we can create this initial state, then as time goes by, we will see that it moves forwards and backwards. And if you do not have computational equipment, we can reproduce a couple of snapshots, and by our human brain assume that in between it will be intermediate grading between this relative heights of these peaks. I think it is enough. We, due to your help, we did 2 lectures in 80% of 1 lecture time. So meeting is done. Have a nice weekend. Is those who completed the homework, just relax. If you didn't, I think it will be like a couple of minutes to write a very brief composition of what you observed in the lab and snapshot the figures. So I'm going to stay here and answer questions if any, but if you need to go, meeting is done. What's the right word? Adjourn is announced. Have a nice weekend. Thank you.